Hello physics class. So we're on to week 2, finished velocity acceleration. Hopefully that was all good for you guys. On to some new content that maybe you haven't talked about yet or looked at before. So first thing is, what is a vector? We're going to be talking about vectors a lot this week and kind of breaking them down, putting them together. But first off, we got to start with what is a vector? So a vector is basically just anything that has a magnitude and direction. If you've ever seen, and you can go back and find the clip, from Despicable Me, there's Vector, the character there, and he says he's fighting crime with magnitude and direction. So that's why his name is Vector. So basically anything that has a magnitude, which means like a speed or a force or something like that, and then a direction. I'm going to use a lot of, it could be a distance as well. I'm going to use direction a lot right now, just because it makes it easy, like a distance and direction. It makes it kind of easy to think about. So let's have an example. So let's say, I'm going to go on this side. This is going to be a vector. Basically, I walked 5 meters, and then directionally this would be east. 5 meters east. Okay? So there is vector number 1 that we can have an example as. You can have vector number 2. We could say you went 7 meters north. Okay, there's a vector number 2. And so those are two very, I'm a little out of the frame. Those are two very easy, simple vectors. Basically, it's 5 meters east, someone walked that far, 7 meters north. You could also say someone's traveling at 5 meters per second east. That would be a velocity, but still a vector because we give an actual direction as well. So that also could be a vector. Again, here you could be saying where someone's traveling at 7 meters per second north. And again, that's another vector quantity, because they both have magnitudes and direction. We can get a little more complicated with vectors as well, as we definitely will. And we can kind of go this. Like, what if I do this? Let's say I didn't walk exactly east, or I didn't exactly walk north. Let's say I did 10 meters, walk 10 meters, but we're going to say 30 degrees, and this would be north of east. North of east. Okay? And so now that's still a directional vector. It's just we're at an angle, okay, which is totally fine. So you walk 10 meters and you were 30 degrees north of east, okay? And that's how you would say it, north of east, because this is technically going straight east and you're going 30 degrees north of east, okay? What we're going to be doing this week with vectors, okay? We're going to be doing two major things. We're going to be combining vectors as well as breaking vectors down. So what do I mean by breaking vectors down? Is an example of this. So this has, like, this is a angled vector, and we can break it down into two things. We can break it down into an x component and a y component. So a y and an x. And we can basically find out, of those 10 meters, when you went 10 meters, again, 30 degrees north of east, how far did you just go east and how far did you just go north? So we can break that vector down into two quantities, okay, which is going to be important to do. So that's going to be one thing that we're going to do this week. As well, we're going to be putting vectors together. And this is kind of where, like I said, the trig kind of comes in. If I go, again, 5 meters east and 7 meters north, like, what is the resulting vector of this? If I did that walk, I went 5 east, 7 north, what was my resulting vector? As in, like, what would this vector actually end up being? And we would have to do two things. One, we'd have to do the actual, like, Pythagorean theorem, like your a squared plus b squared, to figure out the c squared. But not only that, we'd also have to find our angle, as in, like, how many degrees north of east did I actually travel? And so we have to find that angle as well. So those would be the two major things that we're going to be doing, is putting vectors together like this and figure out the resulting vector, as well as breaking vectors down from an actual angle already. So this is a little intro video about what vectors are. Again, anything with magnitude and direction, so it could be meters, just a distance. It could be meters per second, a velocity, as long as it still has a direction. That's kind of what a vector is. So hope this helps out going forward. Thanks, class.